Hello everybody, Andrew Hutchings here, still not a licensed physician and never giving medical advice. And this video is about how we could genetically modify people, for example, to see in the dark. It's something I've thought about for quite some time. It doesn't take a whole lot of thinking because it's very simple. And it's an example I often use in conversation, like when I just had a conversation with my father. But this is the kind of stuff I like, and it's a good example of where we are with science and what's what's possible, and what's pretty easy to do. I'm not saying I can do it because I can't do it with like my t-shirt and my hair. Like, I don't have the equipment here. I can't do it. I don't have a laboratory. You give me a laboratory and you give me enough people to work on stuff, because it's like building a house. You may know how to build a house, but one person trying to build a whole house, it's going to take a long time. It's very doable. It takes time. I think you get the point. So if you wanted to make people able to see in the dark, all you would have to do is genetically modify the proteins in the eyes to react and change shape and elicit a signal pathway in response to different sized, or I don't know what exactly you would call them, wavelengths. I am not a wave physicist person who talks about wavelengths a lot. Like, I know the basics of them, but I'm not sure in all the terminology that would be used. But yeah, different wavelengths. So normally, we see what we see. Certain wavelengths. Ones that are different are like microwaves, for example. The cell phone is shooting out wavelengths, but we don't see them because the proteins in our eyes don't react to them. But if we change, so the stuff that we see, there are wavelengths going through the air. They go into our eye. There's a protein, they hit the protein, and the protein does something, which triggers a pathway and goes to our brain and sends a signal. But when you have like a microwave, for example, it hits that it doesn't do anything, it doesn't send a signal. Only when the wavelengths of stuff we see hit the protein, different proteins, do they do something, send a signal, go to our brains, and now we can interpret it. So you change that protein so that different wavelengths can go and transduce a signal to our brain. It's very simple. You simply have to find a protein that will do some sort of change in response to being hit by your wavelength of interest. So say that is infrared. You experiment and you find a protein that will create a change that can be transduced along a pathway in response to infrared. Say it's microwaves, you do the same thing for microwaves. Once you have created a library of proteins that will change in response to certain wavelengths, then you can go and you can code those proteins. You can code the amino acids that make those proteins into the DNA in place of or in addition to the ones that we normally have in our eyes already. And now, instead of only getting biological responses in response to the stuff we do see, we also get responses to the stuff we don't normally see, because all that stuff is bouncing into our eyeballs, but it's not generating a response. So what we do is we introduce those proteins that are linked up to biological pathways that will lead back to our brain, so that when those wavelengths do go into our eyeballs, that they generate the response and we can interpret it. So to kind of rehash things, we have proteins in our eyes, and when wavelengths hit those proteins, they change. That change is transduced to our brain, which can interpret it. It's why we see. Now, other wavelengths, like microwaves, cell phone waves, infrared, heat. They hit our eyes, but there's no change. There's no signal sent to our brain. But if we change the protein so that it can change in response to those waves and send a signal to our brain, we can now see those different wavelengths. This is the kind of stuff I like, and it's where we are with our science. Because we are in the genetic age where we can make designer human beings. We can genetically modify ourselves. We can genetically modify our offspring. We can make custom organisms. By organism, I mean like custom life forms. We can, I mean, it's not like it just happened yesterday. We've been able to do this for some time now. It's just, depending on what your goal is, you have to spend some time working towards. Like, just because you can do something doesn't mean you can just do it tomorrow. If it's something specific, you do have to spend a little extra time to specifically be able to do exactly that thing that you want to do. Just because you know how to build houses, like, you do still have to plan on exactly what kind of house you want to build and then plan it out and execute it. Just like you can know how to do all this genetically modifying stuff, but if you want to genetically modify the eyeballs, well, like I said, we would have to do experiments to create a library of proteins that will respond to wavelengths. Then we can go, oh, this protein works for this wavelength, this protein works for this wavelength, this protein works for that wavelength. And now we see the amino acid sequence, we code it into the DNA, we put it into the human body, we get it to be expressed in the eyeballs, linked up to our pathways that lead back to our brain, and voila. So yeah, it's cool to be able to see in the dark, but I hope you realize that it's a lot more than that. The fact that we can do this is just an example of what can be done. A cool example, certainly not the coolest. There will certainly be a lot more cooler things that can be done to the human body than simply being able to see in the dark, although that is pretty cool. Perhaps, I mean, it's probably only a matter of time before we can breathe underwater. There are a lot of things we can change. Of course, some people may bring in ethical concerns, and there are ethical concerns. That's not my area of interest. My area of interest is simply doing it, and doing what I want to do, and doing cool stuff. And I hope this opens your mind to the vast possibilities that are possible due to our modern science. But you don't hear people talking about it, you don't see teams researching it. It's not that, I bet there are some out there doing it, but in secret, probably in secret projects. But it shocks me that there's no one like Elon Musk going, hey, let's make people able to see in the dark, let's make humans able to live underwater, let's genetically modify ourselves to be able to survive on Mars. Because we can do it. Hope you like this video. I've got like 450 other videos. My Instagram is